Problem number 7-6. Find the eigenvalues and eigenvectors of the given matrix A, where matrix A is 3 2 and 1 2, and options we have values of lambda and values of eigenvector. So for solving this problem, first we need to find out characteristics roots, where characteristics matrices A minus lambda I we can write as 3 2 and 1 2 minus lambda I, which will be lambda 0 and lambda. We can write directly 3 minus lambda 2 1 2 minus lambda. Now we have to write characteristics equation. So our characteristics equation will become A minus lambda is equal to 0. Now our determinant will become 3 minus lambda 2 1 2 minus lambda equals 0. We will expand this 3 minus lambda and 2 minus lambda minus 2 equals 0. Further, it will be 6 minus 3 lambda minus 2 lambda plus lambda square minus 2 equals 0. It will be lambda square minus 5 lambda plus 4 equals 0. It will finally become lambda minus 1 and lambda minus 4, which will be equal to 0. So therefore we can write lambda is equal to 1 and lambda is equal to 4. So we have two distinct eigen value. Now for solving eigenvector, we taking lambda is equal to 1 for eigenvectors corresponding to lambda is equal to 1. Consider a minus I into x is equal to 0. Then matrix will become 3 minus I, which is 1 and 1, and here 2 and 2 minus I, which is 1, will be equal to x1 x2, which will be equal to 0 0. Applying 2 2 1 1, matrix will be x1 x2 equals to 0 and 0. Now applying operation r2 minus half r1, matrix will become 2 2 0 0. into x1 x2 is equal to 0 0. Now this matrix has rank as 1 and number of variables as 2 and free variables as 2 minus 1, which is 1. So our equation becomes 2x1 and 2x2. So the equation is 2x1 plus 2x2 is equal to 0. Now let us take one free variable as arbitrary as k. x2 equals, we will take x2 as k. So now our equation will become 2x1 plus 2x2 equals 0, and x1 will be minus k. Now we have value of x1 and value of x2. Therefore x1 x2 will be equal to minus k and k, separating variable minus 1 and 1. So now we have eigenvector corresponding to lambda equals to 1 will be minus 1 and 1. So we have got our first eigenvector as minus 1 and 1 corresponding to lambda is equal to 1. Now eigenvector corresponding to eigenvalue 4, or lambda is equal to 4. We will consider a minus lambda I into x is equal to 0. Our matrix will be, we will put lambda is equal to 4. It will be minus 1, 2, 1 and minus 2 into x1 x2 equals to 0 0. Now we will apply operation on matrix R2 plus R1. Our matrix will become minus 1 2 0 0, x1 x2 equals to 0 0. Now this matrix has rank as 1. We have number of variables as 2 and free variables will become 2 minus 1, which will be 1. Now our equation will become, this part is 0, we have only one equation, which is minus x1 plus 2x2. The equation is minus x1 plus 2x2 is equal to 0. Let x2 is equal to k. Therefore minus x1 plus 2k is equal to 0, and x1 is 2k. Now we have two values, x2 is k and x1 is 2k. We will separate our variables. Our values are 2k and k. Separating variables, it will be 2 and 1. Now our eigenvector corresponding to lambda is equal to 4 is 2 and 1. So finally we have lambda is equal to 1 and lambda 2 is equal to 4, and x1, which is eigenvector, which is -1 and 1, and x2 will be 2 and 1. So option C is correct. Option C correct.